sorry. Hello, everybody. Sorry you had to see me today, even though I'm absent. Wanted to remind you, one, that you have a quiz on Monday, and that's going to cover domain and range and all the piecewise functions you did. A lot of the homework that we have is a good place to study. I also sent an email last night. I put a video up on our help videos of me doing a piecewise function. I really recommend you watch that video if you haven't already and tried the problem, and maybe try the problem on your own. I think you tried it in class, but I don't think we went over it. So it's me going over the problem and how to do it. Really recommend that. For today, we're going to basically be doing one piecewise function for practice, finding the domain and range. Actually, we're not going to do a piecewise function. We're going to find one domain and range. Piecewise is on that video. And then we're going to learn something new, and I'm going to have you practice it on IXL. At the end of IXL, I want you to make sure you email me a screenshot of your progress. I want you to email me, take a screenshot and email it to me of where you ended up in class, so I could see exactly where you stopped in class, and I'll give you credit for that many problems. But you're going to need to really watch what I do first. First thing is, go ahead and I want you to read this, and I want you to write the domain and range. So this isn't you doing a piecewise function. This is you finding the domain and range of this function. I'm going to have, you should either pause the video, or Miss Irvine's going to pause the video and let you spend about 4 minutes on this, and then she's going to unpause it, and I'm going to go through it. So hopefully you got a chance to do it. If not, please pause the video and wait, and then play it when you're ready. So in this problem, it says right here that Sam can only work between 2 and 5 hours. So that means the domain would be between 2, including 2, and 5 hours. That's the x. That's the hours he worked. If you put an h here, totally fine, because you could think of the h as being the x. The range is the money. So I could put f of x, or in this case it would be f of h. Or f of x is fine. So to find out how much money he can have, we have to think about how does he make money. Well, if every hour he gets paid, he makes $10, that would mean $10 times the number of hours. But he gets $30 one time. So that would mean the function, in order to find the cost, the money he receives, not the cost, you would have to do 10 times the hours plus 30. Well, the first amount of hours he could work, the smallest amount is 2. So when I plug a 2 in there, I get an answer of 50. Okay? Now, if he works... Now, we're assuming he can work a fraction of an hour. So this could be anything between 2. But the most he can work is 5. So I'm also going to put a 5 in for h. And 5 times 10 plus 30 is 80. So pretty much we know that the lowest amount of money he can make is 50. The highest amount of money he can make is 80. So that would mean the range would be between and including 50 to 80. All right? So now we're going to talk about something that is not going to be on your test, but you're going to have to today do an IXL on how to graph absolute value functions. Absolute value functions are actually piecewise functions. You're going to learn why later, but basically when you do an absolute value function, it looks like this. And if you think of it, it's this part and this part. This is why it's kind of a piecewise function. Okay? Now, as a reminder about absolute value, when you learned in 3rd, 4th, maybe 5th grade, you learned that absolute value is just the distance something is from 0. So the absolute value of 8 is just equal to 8. And the absolute value of negative 8 is also equal to 8. Because negative 8, if you think about a number line, is 8 away from the number 0. It's the distance something is from 0. Okay? So absolute value functions, like the first absolute value function we can graph, is y equals the absolute value of x. So x could be anything. But when you put in numbers, I like to always try numbers like a couple of negative numbers and a couple positive numbers. And this is a function, so instead of y, I could have put f of x. So when I plug in a negative 2 into x, the absolute value of negative 2 is 2. When I plug in a negative 1, you get 1. When I plug in a 0, you get 0. When I plug in a 1, you get 1, because the absolute value of 1 is still 1, and the absolute value of 2 is 2. Now, if you think about what that looks like on a graph, 0, 0, 1, 1, negative 1, 1. It's going to be like the same height, but just going to be, one's going to be at positive 1, one's going to be at negative 1. 2, 2 is about here, and negative 2, because when x is negative 2, the y is also at 2. If you were to start connecting these points, it would go on forever, because you could have an x of 1,000, and your y would be 1,000. So it's going to form a graph that kind of looks like a V. All right? Now, what ends up happening, where this is used in real life, is what is called absolute error analysis. All right? So basically, if I told you that there was this secret number and you didn't know it, and I just told people to guess numbers between, 0 and 20, and you didn't know this, but the actual answer was 17. All right? Well, x is your guess, and y is going to be how far away you were from our secret number. So you didn't know the number was 17, but someone could have said, oh, I think the number is 20. I think the number is 22. I think the number is, oh, it can't be 22, as I said, between 1 and 20. So maybe someone else guesses a 20. Then someone else guesses a 2. And someone else guesses a 15. Well, when you do the absolute value, you don't care if the person is over the number or under the number. You care about how far away from the secret number that they didn't know they were. So this person that guessed 20 was 3 away from the number, because 20 is 3 away from 17. Now it's 3 higher, but it doesn't matter. It's the absolute value of where they were. 20 was 3 over. 2 was way under. But how far away from the 17 was an answer of 2? Well, technically it was negative 15. It was 15 smaller, but we just care that it was 15 away. So the absolute value of negative 15 would be 15. And 15 was 2 away. It was 2 lower, but we're still thinking of an absolute value. When you go to graph this situation, you're going to find that their guess is going to form an absolute value graph. When you were guessed 20, you were 3 away. When you guessed 2, you were 15 away, etc. Okay? So the idea is that it doesn't matter if your guess was above or below. What matters is how far away it was from the 17. This actually, I don't want to get into it right now, but the graph actually wouldn't look exactly like this, because you'd be asking for how much was your guess away from 17. And you would be thinking about that as absolute value. And this is going to actually form a little bit of a different graph. When you graph y equals the absolute value of x minus 17, you're always going to have a positive answer. Because if your guess was 20, 20 minus 17 is still going to be 3. The absolute value of 3 is 3. If your guess was 2, 2 minus 17 is negative 15, but the absolute value of negative 15 was 15. It's still going to be 15 away from that 17. So if you're looking back at this video in a couple days, you're going to be like, Mr. Katz, that was not the right graph for that. But the idea was understanding that no matter whether your guess was above or below the 17, that making it an absolute value equations will ensure that you're just concerned with how far away you are. And certainly if you guess 17, you would be 0 away from the actual target number. Now, this gets into sometimes, and it's actually a good segue into when you have different absolute value equations, your graph is going to shift. Now, this is going to look confusing at first, but when you have an absolute value, this is like your normal graph. This is a graph where it starts at 0, 0, and it goes pretty much up 1 over 1 the whole way through. Okay. When you put a number inside the absolute value, what's going to happen is the graph itself is going to shift. But because this is absolute value, it doesn't, the vertex where the absolute value starts doesn't actually go to the right forward, a positive forward. It actually will always shift the opposite. So x plus 4, absolute value, if you were to graph this, you would actually shift it to the left forward, a negative 4. So this point would be at negative 4, 0. And then the shape of the graph would still be the exact shape. Now, I always like you to get a couple points. So if you know the graph's going to start here, 1 to the right would be an x of negative 3. 1 to the right would be an x of negative 3. 1 to the right would be a x of negative 5. So if you plug those numbers into the absolute value equation, you could find out the y values. And it's actually going to be the same y value because you're moving 1 to the left, 1 to the right. It's going to be the same height. So when I plug in a negative 3, that would be negative 3 plus 4, which is positive 1. And the absolute value of positive 1 is 1. So I know both of these this one would be at negative 3, 1, and this one would be at negative 5, 1. And if you want, you could do a second point by going one more to the right. You could find the value for negative 2 and negative 6. It will be the same point. And that's going to help you graph your absolute value equation. But remember, the number inside is always going to shift your vertex the opposite of what it says. So x minus 4, absolute value, y equals, would make a graph to the right 4. And you could get the other points the same way that we just did. Now, when you have a number on the outside of the absolute value, like plus 3, or you could have like minus 2, this is going to shift the vertex of the absolute value graph up or down, but it's not going to be the opposite. And sometimes students get confused. When it's outside, if it says plus 3, that means your absolute value, instead of being at 0, 0, the vertex is going to be up 3. And if it says minus 2, that means your absolute value graph is going to be shifted down 2. So sometimes you're going to have both those things in there. So let's say you had a graph, the absolute value equation of x minus 1 plus 4. Well, that would mean, ignore that my absolute value vertex is going to be to the opposite of negative 1, so it's going to be to the right 1, and it's going to be up 4. So I know to plot a point at 1, 4. And this is going to go up, and we'll explain why in a second. But if I want to get one more point, this was an x of 1. So 1 to the right would be an x of 2. So if I put a 2 in there, and I do 2 minus 1, which would get me 1, the absolute value of 1 is 1, 1 plus 4 is 5. So my point would be the next point would be at 2, 5. And I know if I go 1 to the left here, it's going to be at the same exact height, so this would be at 0, 5. And then you can make a rough sketch of your absolute value function. All right? Now, the only other things that you need to know are sometimes instead of an absolute value function going, we think of this as like a smiley face, a happy face going up, sometimes you could have an absolute value function that goes down. And the only thing that's going to change when an absolute value function goes down is there will be a negative sign outside the absolute value. Okay? Now, it gets a little bit trickier when sometimes not only will you have a negative sign outside the absolute function, but it's actually also normal to have a function, and I could have written f of x there, that has, like, for example, a 2. Now, there's different ways to do this, but my suggestion would be to, first of all, when you're finding the vertex, that 2, what that does is it makes the absolute value skinnier or fatter. If this is like the normal function, it could make it look like this, or it can make it even skinnier, which we call vertical and horizontal stretches. Ignore this 2 for a second. So the first thing you're going to want to do is get what the vertex is. And we talked about that the vertex would be at negative 1, negative 3. So I go negative 1, negative 3, and I make my vertex. Now I know the vertex is going to be going up because that's a positive number. There's no negative sign outside the absolute value. So to figure out the next point, if I know this is at an x of negative 1, then I might plug in, make a table, where instead of negative 1, I know it was negative 1, negative 3, I'm going to make an x of 0. I'm going to go 1 to the right. And when I plug in a 0, 0 plus 1 is 1. The absolute value of 1 is 1. So you have 2 times 1 minus 3, and you have to multiply first. 2 times 1 is 2, minus 3 is negative 1. So I'd go to the point 0, negative 1. And then I know where x is negative 2, it's going to be right along that side. So maybe I go one more, and I go to x of 1. So I plug in a 1 into this equation. 1 plus 1 is 2. The absolute value of 2 is 2. 2 times 2 is 4. 4 minus 3 is 1. So I know my point is 1, 1. And then I know on the other side, when I move over 1 to the left, it's going to be at the same spot. And that's going to allow me to make a rough sketch, hopefully you go through your points, of the absolute value. Now, as a reminder, as you do your IXL, that is upside down. If you ever get stuck, I think a lot of you will be able to do this right away, but if you get stuck, there's a button that says Learn with Examples and Watch Video. Please make sure you do those things, but you're going to want to get as high as you can. I'm going to, this is on IXL, it'll be BB2, graph and absolute value function. You should see it tomorrow in your IXL. Make sure you send me a screenshot. And what you're going to do, remember, is once you're done, you're going to send a screenshot of your work to my email address, which you should already have, but in case. It's this, oh, that's upside down. Sorry about that. Stephen.katz@mcpsmd.net. Okay, and you just take a screenshot of your, basically what your SMART score is, and have a great day. And I hope that helps. Please make sure you study for the quiz which we have on Monday, which remember will not include this absolute value stuff.